mostly you got this. For this vector, we knew we were in quadrant 1 because the coordinates of the endpoint of our vector are 1, 2. That's where that 1 in front of the I and the 2 in front of the j came from. So the first thing I need to do is find the magnitude of my vector, which is going to be the square root of 1 squared plus 2 squared, which is the square root of 5. So once I have my magnitude, I use the formula for the a. The a in my vector is 1, so I have 1 is equal to the square root of 5 times the cosine of theta. I divide both sides by the square root of 5, and then I take the inverse cosine. And we squeak. And that's about 63 some odd degrees. Which makes sense because we are in quadrant 1. All right, let's see what else we have to do. Remember we mentioned that we could add and subtract vectors and we could multiply them by numbers? Guess what? The adding and subtracting is really easy. Forget that. We know how to find magnitude. Let's add our two vectors together. What do you think I need to do to add u with v? Add like terms. So my like terms are negative 3i and a 10i, so I'll add them together. So u plus v will be negative 3 plus 10i. And then negative 7 plus, so plus a negative 7 plus a negative 8j, and then simplify. So this turns out to be 7i minus 15j. I know I went the hard way. Probably could have just done negative 3 and 10 is 7, and negative 7 and negative 8 is negative 15. I know. Now, one thing you do need to make sure you do is pay attention to what you're being asked to do and in which order. If you have something that said the magnitude of u plus v, what would you have to do first? Add them, and then you get to find the magnitude. I noticed in the homework that's one of the places where people miss it. They are happy to calculate magnitudes, they think that's easy, but then they add the magnitudes and it doesn't work out that way. All right, you guys can find u minus v. Same u and v. Order does make a difference. You're subtracting. Right, you subtract the numbers. All these negative signs just drive me nuts, and you're going through fixing it. I plus negative 7 minus negative 8j will give us negative 13i plus 1j. And you don't have to write the 1 if you don't want to. Oh, but in WebWorks you probably are going to have to because you have to go in blanks. Now, this is even easier. What do you think you do to do 4 times v? Yeah, it's just multiply 4 by each of the pieces. So 4 times v is going to be 4 times, this is v, so 10i minus 4 times 8j, which will give us 40i minus 32j. Yeah, multiply that right. It's kind of sad. I was checking my son's homework this morning with a calculator. I don't even want to think about what 3/10 is. You want to to do this one, or do you want to say, I can handle that? You can handle that? Because I'm pretty sure that the only thing that's left, real quick, is the unit vector. I got 4 minutes. Yeah, don't worry. I'm gonna watch you slow. To find the unit vector, basically you take your vector and you divide it by the magnitude of the vector. When you do this, when you recalculate the magnitude of this new vector, it's only going to be length 1. So this is how you get it to there. The magnitude of this new vector will have length 1. So all you have to do is calculate magnitude, just like we did here. And then when you write your vector, it would be -3, for instance, over the magnitude I, -7 over the magnitude j. So it's not all that difficult a thing to do. Just because once you find magnitude, it's easy. Because you're multiplying now by this 1 over that number. Well, because usually you write them, it's over the same, for the same vector, the number, if you divide this by, like, the square root of 9 and 49 is 58, square root of 58. You could just write it this way, divided by the square root of 58. But in WebWork, you have to break them up into the 2 pieces, so it would be -3 over the square root of 58 and -7 over the square root of 58. That's why I said them separately. Next time we're going to do dot product.